Hello and welcome to this session called Inside OCR and Form Recognizer. My name is Sanjeev Jagtap and I'm a Senior Program Manager in the OCR and Form Recognizer team. So we have a lot to cover, so let's get started. What we do as a team, our goal, our mission is to take all text and intelligence from the text content in our documents, images, and even physical objects and enable our customers to implement the three big scenarios of business process automation, knowledge mining, also called information search and retrieval, and industry specific applications depending on what they are trying to do with this content. How we do it? Well, there's one group of customers who will come and use our OCR service to get all text lines and words, and then they will apply their business logic, business rules, post processing of those raw text to enable those three big scenarios we talked about. Well, other group of customers, they actually want those kind of information and document understanding insights on top of the read text itself so that they can fast track their journey to the same scenarios. And for those customers, they come in through the form recognizer product. And that's what they use to get the layout, such as the document structure, pre-built. For example, understanding invoices, receipt, business cards out of the box, right, and getting those insights versus having to process it after the fact. And also building custom models to understand their custom documents. So all of that document understanding functionality is offered as part of Form Recognizer as a layer, and Form Recognizer does use our read service internally to start from a text as the baseline. But the idea is that customers can come in through either through OCR and use that and apply their business processing, or they can directly use a Form Recognizer to get those insights out of the box for their application journey. So at a very high level, the way OCR works is with a couple of read operations that are part of the computer vision API in cognitive services. The service takes in images and documents, primarily specifically PDF and TIFF documents here, which can be multi-page, up to 2000 pages long. And this service will extract text lines and words and some other metadata in form of a structured JSON output that you can integrate using the Cloud API or the SDK. And all of this, by the way, is also available for on-premise deployment as Docker containers. So digging just a step deeper, the way you call the read operation, like any other Cloud API, is calling the endpoint, URL endpoint over HTTPS and using your API key from the computer vision or cognitive services resource and calling the read operation here. And the read operation is an async process because it has to process a large and a number of documents which can have a lot of text in it, and therefore it does not return immediately, but it returns an operation ID that you use to call the get result operation along with your API key, and then keep monitoring the status of the get read result operation. And that's kind of the general pattern that you will find across all of OCR and form recognizer methods, which are or operations which are asynchronous. And so the idea here is to keep polling the read result status until you're done. And when the operation returns a status of succeeded, it will actually also return a complete JSON output with the text from inside the document or the image, which you can use. And yes, the service will delete all customer data and all results within 48 hours. So we don't store any data, any customer data for training or improvement of a product or service, and no one has access to your data. It's secure in the customer accounts. In addition, customers can use virtual networks, IP firewalls, and private endpoints. Effectively, all of Azure and cognitive services security features are available to use with Read. And these are kind of some of the input details where we support, like I said, large number of pages in a document, large file sizes, and large document page sizes as well when it's a PDF. All right. So now that we have seen how the read operation works, let's look at some sample code. And this code uses the .NET SDK, but we also have the Python, Java, and JavaScript SDKs available. So either you can call the REST API directly, or you can use the SDK. So in this case, this is an example of how using the .NET SDK, you can call the read service. So in this first step here, we are reading the text from the URL. All right, this is there's a URL to a file that we are passing to the read async method of the SDK, and that starts the process of analyzing the documents. And notice this operation location that I'd mentioned before. So that's what you save to use later with the get read result operation as we had talked about, right? And then you kind of keep polling it until the status is running or is not started. In other words, once the results of status is succeeded, then you can now get the results of that process and then really just print out. In this case, this code really just prints out all the text line wise onto the console. So really simple. Get three-step operation, three-step code sample here. Submit the file, wait for it for the analysis to complete, get the text, and then display it. All right, that's pretty much it. So now let's step back and look at the read journey, as I like to call it, because we have had some multiple versions of this, the OCR functionality over the years, and so therefore customers and partners are going through this journey. And so let's kind of go through it quickly to understand where read is today. So the OCR is the original operation that we had before in 2016, which is still there. It was traditional machine learning, images only, small file sizes, right? And it was designed for text-light images. And then came the first generation of the deep learning-based investments that Microsoft made with Microsoft Research and Engineering in a big way, starting a couple of years ago. And the recognized text operations or API that a lot of our customers partners started using is an example of that first generation API, which is being deprecated right now. So what we have today is the Read 3.0, which went into GA in May earlier in the year, and now we are on to the previews. But Read 3 is really onwards is the preferred and the new unified technology stack or platform for all those capabilities moving forward. And so that's what customers and partners are moving to very quickly here, and that's what we are recommending, because as you can tell, this was still the first generation stack here, and so the recognized text was could handle only images only and small file sizes. The read file was the deep learning based model. In case of read 3.x, we now have universal language models, mixed languages support, mixed print and handwritten support, and that means your documents and text lines within the document can have multiple languages and even mixed print and handwritten text, and all of that is detected. Plus the big theme over the next few months will be the language expansion features here for read 3. So for all practical purposes, in terms of languages, features and AI quality roadmap, read 3.0 and onwards is the preferred platform for customers to adopt. The next few slides, I'll go through them quickly, but they kind of showcase the quality of the new read OCR especially for text-intensive documents and images, right? And so this is an example of an article, and you will notice the text lines that was recognized here, and also the bounding box or the location of that line, which is what you can use to layer rendering. So it's just exactly like this image that has the highlighting implemented on top of it. This is again another example here. So this slide is showing an example of I guess we call it in the wild or general images here again. So these are really images of street signs, retail shelves of all kinds, but the OCR service is able to recognize the text even when the images have a certain perspective or an angle to it, and so on, right? And then of course where it really shines is documents. And so this is an example of a case study or a brochure. This is a poster, and again you can see the text being extracted, detected. That's an example of a scientific document. This is also where the OCR can be very handy, which is recognizing the text in large engineering or technical diagrams here with a lot of small text in a big image size. This is again an example of a document, and notice these table lines that got rendered, and we'll talk about this later, which is part of the layout understanding. And then again another example here, right? So remember I talked about the language expansion roadmap of the read service. So right now, as part of the public preview, we have the simplified Chinese support, available right now. So this is an example of a Chinese text form, and you can notice that the text lines, both English here and then in this case simplified Chinese, were both recognized, right, along with their location. This is an example of a Japanese text form, and again you can notice that both English as well as the Japanese text lines were recognized along with their bounding boxes and locations. Another example of mixed Latin languages here that was all recognized. English, so Read service also has pretty good English handwritten language detection extraction support. And so that's an example of the OCR working and extracting all the text in this handwritten note. Those are certain Japanese newspapers. Even rotated text, for example, in this tire image, for example, is extracted by the OCR and detected successfully, right? Again, in another example of a table, as part of the layout understanding service, not the read, but the layout understanding that we will look at a little bit later. And another one here. So now that we have looked at all the read and OCR capabilities and features, let's review what's new in the read 3.2 public preview, which is the latest version out today. So for one, it supports simplified Chinese and Japanese. It has handwriting classification for text lines, and we'll see an example of that in a second here. And also for large documents, you can now select specific pages or page ranges for analyzing and extracting the text, just like you would use a print command with large documents for printing, right? And of course, it's all available as containers. So in these screenshots, notice that this text line was actually recognized as being of a handwriting style text, right, versus the other style. And then here you'll notice this was a 500-page document, but I wanted really just 5 pages from 200, page number 200 to 205 to be analyzed and printed, and that's what I was able to specify. And this comes handy if you really want selected pages from a big document here. And of course, all of this is available as a Cloud API and Docker container. All right, so that was read and OCR. Now let's talk about form recognizer. Right, so I think right away it will be clear that form recognizer, let's say if you wanted this the tax form like this to be passed to the service, and you wanted the field value or the key value pairs to be returned, such as this example shows here, directly without doing any processing, that's what form recognizer allows you to do. Versus if you were using the read service, then you would have to understand the location, the structure of the document in your code, hard code the parameters here, and then try to extract these relationships such as name, spouse name, social security number, address, and so on. Right. So let's kind of keep moving on the form recognizer feature here. So form recognizer at a very high level is composed of the layout service, which gives you the document structure and the text. So remember, text comes with the form recognizer features by default because it uses read or OCR under the covers. And so for document understanding information, use the layout service. We also offer pre-built models for recognizing invoices, receipt, business cards out of the box, right? So you don't need to build custom models for that, and you don't need to do any post-processing on top of the OCR output. And then the third category is, of course, custom models. So for documents that we do not provide pre-builds, and also for which the post-processing will be heavy, you can actually build your own custom models very easily and quickly with the form recognizer service, depending on your document needs and formats. Okay. So from a REST API and SDK perspective, the same three categories. So there are APIs available, and you will notice that for layout, pre-built, and custom, you have the corresponding APIs, REST APIs available. So in this case, you have the analyze layout and the get analyze layout result operation, similar to read and get read result operations here. For pre-built, I'm showing the analyze receipt one. But we also have the business card, and actually if you go to the website today, you will also see an analyze invoice set of operations as well. And this is really how the service, you can use this programming interface to build custom models that I was talking about. Right? And on top of the API, we also provide some excellent SDKs for you to use, which makes it easier to use these APIs. And so it's up to you and our customers and partners whether they want to directly use the REST APIs or use one of these .NET, Python, Java, and JavaScript SDKs to go with that. The service also includes an open source labeling tool to kind of make it easier to build these custom models. Remember, these building custom models with labels requires labeling your document fields and the keys effectively, all right, for those values that are in the documents. And so, just to make that process easier and faster, we provide an open source labeling tool for you as well. All right, so let's now talk about the layout, the first category of features in Form Recognizer, which is layout. So to see an example of how a layout works, let's take this document here, right? And you can notice this is an extract from a financial report. It has certain text laid out, and of course, if you run OCR on it using the read service, you will really get all text lines and words, but with no relationship between them in terms of their layout or their arrangement in the document. But if you use the layout service, the service recognizes that these are really three tables with certain columns and certain rows of text, right? And so what it will do is you are able to then process it in your application. So notice the JSON output here. So if you look at the read result, there's a read result object right here, right, which contains the text. And then notice this new page results object, which has the three tables that the service recognized, including the rows and columns, numbers that you can see that was extracted. And if I expand the sales object here and the collection more accurately, then you can notice that it has all the cells in those tables, complete with the row index and column index to denote which cell are we talking about, along with the text line. And then the actual words are pointing really back to the read object, read results content here in terms of a pointer, right? So think of, realize that now we have layered the layout information as the page result object on top of the read result, which is the plain text information. So here's another example of a document where the service recognizes it's a table and outputs it in the same JSON format that we saw. And also the layout will also recognize your checkboxes. So notice this Chinese tax form that we saw earlier. So the service does recognize the checkbox, and it will again output these in your JSON response from the layout service, along with a selected state as well. So as you can see here, it says selected and unselected for the particular sample I used with the service. All right, now let's talk about, let's look at some code sample here. So just like read and get read result, all right, so you could use the layout API as well. So this for this code sample, I'm using the Python SDK to make my life easier. And so you will notice I'm using a sample document. I'm using the endpoint, and I'm using my API key or the credentials, and instantiating a form recognizer client here, right? Ignore the training client line. I don't need it here, but we'll need it later. And so the first step is to initialize your service and build your client. And then right here, I'm actually giving it the URL. I'm calling the layout as operation essentially here, and asking it to recognize the content, right? And then and then I'm printing out a table. If the service detects, or the layout detects a table, then I'm printing it out. And then once the table is detected, after that, I'm really printing out, taking that table and then iterating over the cells, right, of the table, and formatting it so that it looks nice and so on, a little bit nicer, similar to how it appears here. And so the output from the step 3 is, you can see the output right here, which corresponds to the content you see in this document here. So that's kind of an example, very simple 3-step example of how the layout API within Form Recognizer works. So the layout service now features a new enhanced table extraction with the public preview that went live last week. And so if you have used this feature before, you will be surprised at how significantly better this feature now works with the new table engine. So in this case, this document had these 4 tables, out of which I'm showing the 3 tables here that were rendered by the open source labeling tool within that. So absolutely try out your documents and the tables within those with this service if you haven't tried it before. Okay, so now let's take a look at the pre-built models within Form Recognizer. In this case, we'll take the receipt example. Remember, Form Recognizer has three categories of features: layout, pre-builds, and custom, right? So we are right now looking at pre-builds. In this case, when you use the receipt API or the receipt operation of the Form Recognizer, all you have to do is submit a receipt image like this to the service, and the service will directly extract the key value pairs from this receipt without requiring any post-processing or any building of custom models. Right, and if you look at the JSON response, you will notice that the cup fund donation value is coming for the item's name key, and then also the price, the total price, which is $5, is coming right from this field value here. And so what you get is a collection of key value pairs out of the box from this receipt image, really, and there is no other processing required. And that's the power of the out-of-the-box pre-built models that are part of Form Recognizer. Right. So now let's take a look at the a sample code that kind of shows the same use case here, but uses the Python SDK of Form Recognizer. So this is my reference image that I'm going to test, right? And so that's the URL to this image, which I'm passing to the begin recognize receipt from URL method of the SDK. And then really all I'm doing is iterating through the key value pairs of the JSON result that I get from the service. Right, and so now that's the output from this code sample that I got, and you will notice that all the key value pairs from the receipt were correctly extracted by the service and output to the console. And again, so all I needed to do was take the receipt image and then submit it to the service, and then just list out the output from the service. That's pretty much it. We also have more pre-built types now available. In addition to receipt, we have invoices and business card models available. And the usage and the programming is exactly the same as we just saw for the receipt example in the previous slide. Right. So now let's look at custom forms. Remember, if you want the document structure and text information, then you use the layout API or the layout feature. If you want out-of-the-box model recognition of receipts, invoices, business cards, then you use the pre-built. But let's say you have other documents that we don't have pre-builts for. That's where you come and build your own custom models. Right. So in this case, in this example, I guess I had a W-2 form which I want to be able to recognize using the service. And so all I did was, take 5 to 7 documents, build a custom model, and then apply it to my test forms such as this one. And in return, what I got was the same key value pairs that we saw in the previous example, except these are coming because of my custom model that I trained by taking a few sample documents. And you will notice in the JSON response, again, the same idea here that the company, in this case, the employer name, address, and zip code is coming out. This is the employer name here. And then the key, the 3 dot social security wages, which is this key, right? And which is really, yeah, from this form here. And then the value, $70,000 is coming from the form as well, right here. That's the key value pair that I'm essentially listing out from this JSON response. And again, the difference here was that I built a custom model and then applied it to my test document, right, versus calling the service directly. So now let's take a look at how the sample code looks like in this case. So this code is also uses Python SDK, and it is split up into 2 slides or 2 steps. The first steps, remember, is to train and build our custom model based on our input. So let's go ahead and do that. And so the first thing you will notice is the training data URL. So this is really a pointer or the SAS key to SAS URL to the my location of my training data in Azure Blob Storage container, which I'm passing to the begin training method here, right? And then telling the service to train a model for me, and then return the model information back to me here. Right, and so if I run this code, what I get is a model ID. That's my trained custom model ready for me to use, along with some training metadata such as timestamps here, right? But then the question is, well, that's great. I have those 5 forms that I now have a custom model trained and ready to use. But what are the fields that the model recognized as a result of those training data? And so all I'm doing here is listing out those fields, and you will notice that the output correctly lists out saying that the form has recognized the following fields as address, charges, invoice date, invoice due date, and invoice for, and so on. And so what I now have is a custom model ready to be applied to my test form. So let's move on to the second step, right? And so my test form is right here. That's the form that I'm testing my model against for. And so that's the step 2 analyze method, again using the Python SDK. So let's get started. So as step 1, I remember that model ID that I got from the previous step. That's right here. I also have the URL to this test image, and I'm calling the begin recognize custom forms method of the SDK, right? And then getting back the result. And then all I'm doing is, as a second step, iterating all the fields and their values that the model recognized from this test form. Remember, this is the form I have not used for training. That's a test form. And so now if I run this code, you will see the console output with the fields recognized, right, along with the values and the confidence scores of the service that it was able to match these values to the keys. So that's an example of where we built a custom model in step 1, and then we analyzed a test form with that model, right? And then we got the results. All right, let's try some demos using the form recognizer open source labeling tool that we provide as part of the service. And you can find the link to the site here from the documentation. But let's try the layout demo here. And so here you will notice I've got my endpoints, I've got my API key. And so remember, layout gives us tables and selection marks and text from a document, right? So let's try that. And so that's my document. I'm using the layout service. And so now I will call the layout operation that will do the analysis of this document. And once it returns, we'll see 2 things. One is the text, the highlighted text. And let me actually zoom in here a little bit, right? So notice the text here that you see, which is highlighted by the OCR service. And then these icons show you the tables that were recognized and extracted, right? So if I click on this table, you can notice that it's 2 columns and 4 rows that were extracted. And if I click on this icon here, you can see that's the table got extracted. So very quickly, this is the layout, read text and table extraction demo here, right? All right. Now let's go back and try the pre-built models. Remember I said we have Form Recognizer has the pre-built offerings for receipt, invoice, and business cards that are in public preview today. So let's try first the receipt one. And again, notice I've got my endpoint and I've got my API key right here. And so let's find a good receipt to test. And so if I go into the pre-bills here, and then I get, let's say, this Walgreens receipt. And so notice that that's my receipt image, and what I'll do is I'll run analysis. So right now it is calling the the analyze operation of the receipt service, and right away you will notice that it will extract the key value pairs. And let me zoom in so you can see better. Right, so those are the key value pairs, and then if I scroll down here, you will notice all the text such as the total price, the item name, and the item name of this price here, the merchant name as Walgreens, that was all extracted correctly, including the total, right, and the transaction date that's coming from here and so on. So that's the example of how the pre-built receipt works. Right. Now we could also actually try with an invoice. Let's say, for example, so let me select an invoice, go browse, and pick this one. And let's run analysis on it. And so once the invoice analysis call succeeds, again, you will notice that it recognized a number of information fields from inside the invoice without any custom training at all. I don't have any custom model working. This is the pre-built offering. And if I scroll down the tags that were detected, notice, that's the so those are the key value pairs here. For example, previous unpaid balance was $500. That's the invoice date, due date, right, and the customer name, and so on. So that's an example how a receipt or an invoice pre-built offering works. All right. All right. So remember, I said the form recognizer also offers a custom training offering where you can build custom models for your forms that are not supported out of the box by form recognizer. And so here I'm trying to make a build a model for W2 for recognizing W2 forms. And so this is the open source labeling tool that you can also use. And the link is there in the form recognizer documentation. So you can navigate to that link from there and set up your own projects and carry out these labeling tasks and try out layouts and pre-builds like I did before. All right. So in this project, I've got some of my forms, WT forms uploaded in the storage in the training data storage in Natural Blob Storage. And so that's where this tool picked it up from. And I gave the SAS URL to the project settings page here. And so what you see here is some documents here, and the ones with the green icon have been labeled and trained, but the ones with the brown tag here, they have been labeled, right? So it says manually labeled, but they haven't been included in the training iteration. So now we will go ahead and actually ask the service to train this model, and I'll give it a new name. I'll say W2 new. And now what the service is right now doing is training a new W2 model for me based on those two new documents, right, that I added. And that's kind of the prediction accuracy that is predicting. And you can see the model ID here, the new custom model that we got just now, my model name, and then the model the created date and time. Okay, all right. So now let's go ahead and come back to the. By the way, this is the model compose feature where you can combine multiple models and then use that to analyze. But now let's go ahead and try analyzing using our new model name. So notice the model name now says W2 new. So all I need to do to test this model now on an untrained document is to browse for a test W2 form. Right, so let me go into custom. And I have some W2 forms here. So those were the training documents. Let me go into test and select this one. All right. And now I'll run analysis on it. So what the service is doing right now is applying the new model, W2 new, to this untrained, untested document here. And so from our code sample, if you can relate to, that's our step 2, right, of applying analysis using our custom model. So notice that it took our trained model and applied it to document. And actually, if I go and look at the tags, it correctly identified the employer name, employer ID number, the addresses, and all the other fields that are coming here. So for example, Medicare tax is 1450, which is right here, right, and so on. So that's an example of where I built a custom model, and all I needed was to upload these 5 to 7 documents, and now I have a model ready for recognizing W2 forms. All right, that's pretty much it. Thanks. So now let's take a look at what's new in Form Recognizer. As of last week, we published our Form Recognizer 2.1 public preview, next release, which now supports these languages from English to French, German, Italian, Spanish, Portuguese, Dutch, and the newest languages, Simplified Chinese and Japanese. We now have enhanced table extraction engine. Checkbox selection mark detection has been enhanced. Model compose is a pretty important feature because let's say your enterprise or your company or your customer has tens and tens of different document sizes, in fact, up to 100 different document formats. And so what you need to do there is build multiple custom models. But using Model Compose, you can tell the service to combine all of those models into one single model ID and then use that for your prediction. And that's the power of the Model Compose feature here. We also now have pre-built models for business cards and invoices, new English locales for receipts. And by the way, all of this is available for on-premise deployment as part of a Docker container preview. That's available as well, along with enhancements to the open source labeling tool that we have been seeing some screenshots from as part of my slide demos here. And so the open source labeling tool kind of makes it easy to provide and create the labeling data that the service needs for building custom models. In terms of the resources, these are the URLs that you can use for form recognizer documentation, read OCR documentation, and that's the contact us alias formrec_contact at microsoft.com is the email address where you can reach me and my colleagues in the team here with any of your questions. And that's it. And thank you so much for attending the session.